Hello and welcome to today's revision session on GCSE Physics Paper 2 for Separate Science. So what we're going to do in today's revision session is we're going to look at how we can answer examination questions on GCSE Physics Paper 2 in the AQA syllabus. So if we've been successful and learnt in today's revision session, we should be able to answer GCSE Physics examination style questions, assess your understanding on GCSE Physics, and finally understand what topics we need to improve upon for GCSE Physics. So when carrying out this revision session, I would recommend you do the following. You would get a piece of paper and divide it into two sections. Make the section on the left hand side larger than the right hand side. So what you would do is in the left hand section you would write down your working out and answers to the questions in the revision session. Now when you do this, make sure you write out your answers in full sentences and show your working out. In the right hand section, write down any pieces of information that you find useful or any hints and tips on answering questions from this revision session. After the end of the revision session, write up these notes into a revision sheet for you to use independently. So what we're going to do for the majority of this revision session is we're going to look at questions from GCSE Physics Paper 2. So the first topic we're going to look at is forces. So let's have a look at the following question. The student increased the resultant force acting on the glider by adding more masses to a mass holder. She calculated the acceleration of the glider for each resultant force. Each test was done 3 times and table 1 shows the results. So the student made 2 mistakes in the mean acceleration column. Identify the mistakes the student made and suggest how each mistake can be corrected. So pause the video now, have a go at answering the question, and when you want to go through the answer, unpause the video. Right, so when you look at a question like this, it's very important that you look at all the information given to you. So the first thing that stands out to me is that you'll notice the number of decimal places. That in the first row, the number of decimal places for the mean value is actually 5, but in every other one it's going to be 1. So that tells us that that's not going to be right, because that's standing out. Now again, we don't really talk about decimal places in physics, we talk about significant figures. So you would say that the first row has an incorrect number of significant figures. It should be given to 2 significant figures. Now what else do we know about calculating means? Well, we know we calculate means by adding up the values that we tested and dividing by the number of values. So you would have a look to see if those calculations were right or not. And then finally, what also you need to talk about, the idea of anomalies. When you are calculating a mean value, you should be discarding your anomalies before you then calculate your mean. So from looking at these values, I can see that in the final row we've got 6.4, 7.2, 6.4. Well, 7.2 stands out as quite significantly different, especially when you compare it to all the other rows, because in all the other rows they're out by about 0.1 from each other, but in this one it's quite significantly out. So our answer is firstly that the first row is wrong because the value should be given to 2 significant figures or 1 decimal place, and the answer for 6.7, the last row, is wrong because you should be discarding the anomalous result and recalculating the mean. Let's have a look at this question. The white ball is thrown high into the air. After it is released, the ball moves up and then back down in a vertical line. The free body force diagram in figure 6 shows the forces on the ball at one point in its flight. The force arrows are drawn to scale. Explain what is happening to the ball at this point in its flight. So pause the video now, and then when you want to go through the answer, unpause your video. So let's have a think about what's going on. Now the first hint they give you in this question is they say that the force arrows are drawn to scale. So you can see quite clearly that from this particular information that the arrow up and the arrow down are the same length, so therefore the forces are of the same size. So we can say that the 2 forces, the air resistance and the weight, now remember weight always acts down and air resistance acts against the motion, so these 2 forces are equal in size but are in opposite directions. So therefore there's no resultant force. Now a key important principle in physics is that a resultant force causes an acceleration. So if there's no resultant force, and we know this because the 2 arrows balance each other out, there must be no acceleration, or it's at a constant speed. But you've also, to get the full marks, got to read the question. So the question tells us it's moving up and now it's coming back down. So the idea is it's not stationary, it's in fact moving down in a constant speed because it's already moving down. Now, what do we call this in physics? Well, we have a special name for when an object falls with a constant speed because the forces balance out, and that is the terminal velocity. So when we look at our answer, you would say firstly the ball is falling or moving down. It tells you that in the question that it's falling down, so make sure you read the information in the question at terminal velocity, because the air resistance and weight have the same magnitude or size, so there's no acceleration, there is constant speed. Let's have a look at the next question. A man is driving his car at a constant speed on a wet road. He sees a fallen tree on the wet road and tries to stop quickly to prevent an accident. Explain why the man may not be able to stop in time. So pause the video now, and then when you want to go through the answer, unpause the video. Right, so the first thing that I look at in this question is it's worth 6 marks. So I've got to think to myself, I've got to really plan out a thorough answer if it's worth 6 marks. Because a lot of the marks in these types of questions not only come from the physics which you discuss, but how you organise your thoughts and your ideas in physics. So we're talking about stopping on a car. So we're talking about the idea of stopping distance. Now you should remember that stopping distance is equal to thinking distance plus braking distance. So one paragraph should focus on braking distance and another paragraph should focus on thinking distance. So let's go through each aspect at a time. So the factors that affect the thinking distance are: the driver could be distracted, the driver could be tired, the driver could be on medication that affects the thinking, the driver could have drunk alcohol, and also that will mean that the reaction time will be longer, so they won't break as quickly. Remember, basically, the thinking distance is the distance you travel whilst you think about pressing the brakes, but the time it takes for you to observe a hazard and then press the brakes is called the reaction time. Now, AQA especially like you to talk about reaction time and link it into this thinking distance. Now, let's think about the factors that affect the braking distance. Well, the condition of the car. So you've got warm brakes, you've got wear on your tyres, the speed the car is travelling at, and finally the condition of the road. So the road is wet, so therefore the friction between the tyres and the road is reduced. So always try and link it into what's going on and how that would affect your thinking and your braking distance. So don't just say the condition of the car, give an example and say that the brakes might be worn, so that would increase the braking distance. Or you don't just say the condition of the road, say the road could be wet, so therefore that increases the braking distance. And remember to talk about them in different paragraphs as well. Always have a structure to your answer. Let's have a look at another question. Figure 10 shows the horizontal forces acting on a man swimming in the sea. Describe the movement of the man when the resultant horizontal force is 0 newtons. Then the man increases force A. Explain what happens to force B and to the movement of the man. So pause the video now and then unpause the video when you want to go through the answer. Right, so first thing we note again is we look at the size of the arrows. Now you'll notice in the size of the arrows they are equal to each other, so therefore the two forces cancel out, and we know this because it says in the question the resultant horizontal force is 0 newtons, so they must cancel each other out. Now you can see quite clearly that the swimmer, the man, is moving forwards. Now remember, if there's 0 newtons acting on the person, if there's no resultant force, they will not accelerate, they stay at the same speed. So if they are moving forward with a speed, it will stay at that constant speed. Now it's probably better to use the phrase constant velocity because we also indicate our direction with that, because velocity is speed with a direction. Now the man increases force A. Explain what happens to force B and to the movement of the man. So if we know force A is bigger, that means there's a resultant force forwards, so the man will accelerate forwards. Now if you think about it, if they're accelerating forwards, it means that they're moving faster. Now what causes force B? Well, force B is the frictional force, which is caused by the swimmer moving the water out of the way. So if they're moving faster, they're moving more water out of the way. So as a result, that means that force B will also increase. Now if you think about it, the faster the person goes, the more force B will increase because the more water you're pushing out of the way. And at that point, eventually the two forces will equal each other. So once again, the resultant force will go back to zero. And when you go back to zero, always state what happens to the velocity. You will go back to a constant velocity. You will go back to the same speed. It is higher than it was before, but has once again gone back to a constant velocity. Always think about what's going on in terms of the velocity and the acceleration. And always remember, a resultant force causes an acceleration. Let's look at the following question now. Two girls, A and B, ran an 800-meter race. Figure 2 shows how the distance changed with time. Compare the motion of runners A and B and include data from figure 11. Right, pause the video now and then unpause the video when you want to go through the answer. Right, so once again, this question is worth 6 marks. So I've got to think to myself, how am I going to think about what's going on with this particular this idea to structure it into some paragraphs? So I've got to think about either talk about A and then B, or I could talk about different sections of the race. Now, I'd probably want to talk about different sections of the race because it has this word compare in the question. Now, the word compare means that we're going to have to look at what A and B are doing and reference them against each other. Don't just talk about A and talk about B separately, link the two together. Now, the next thing, it says include data from figure 11. Now, it's very important you know what you're working out from all the graphs you use in physics. Now, in a distance time graph, what's the important thing you can work out from the graph? Well, it's the gradient, because the gradient of a distance time graph is the velocity or the speed. So let's just think about what's going on. So we know that at the lower times at the start of the race, A has a constant speed. We know this because the line is straight. Now you can then tell it's going to slow down because the line is starting to curve, and then eventually, okay, it's getting slower and slower because the line is curving more and more. Now it'll be really useful as well to actually calculate the gradient for the straight line section. So in the straight line section, which is going from about 0 to 60 seconds approximately, you can work out what the speed is because you can read off what the distance is, approximately 440 meters. So you do 440 divided by 60 and that gets you your constant time. Now we can then look at B, and you can see that B is starting off at a lower speed than A. We know this because the line is lower, so the line is below, so the gradient is smaller, but it's getting faster and faster and faster because we know that the gradient is going up because it's getting steeper and steeper and steeper. Now you've also got to be able to compare the two. So you'll notice that B overtakes A at a certain section at approximately 700 meters. We know this because the line goes above A. So talk about that, and then finally look at where we get our final answers. So compare the motion, who won the race? Well, you can tell B has won the race because they've reached 800 meters first, because they reached the value in 126 seconds while A reached it in 160 seconds. So they beat them by 34 seconds. So let's have a look at our answer here. So if you have a look, you can see here some indicative content. So like we talked about before, we talked about A, we talked about B, we then linked the two together by talking about when B overtook A, and we also then talked about how B won the race. Now it's also very important you try to work out some values. You don't just say A started off faster and B was slower, and then eventually B got faster, then A overtook. If you want 6 marks, if you want a level 3 answer, you need to calculate some values. So you need to work out some of the answers. Right. So let's have a look at another question. A skydiver jumps from an aircraft and after 25 seconds reaches a maximum velocity of 50 meters per second. They then fall for a further 200 seconds before opening their parachute. What is the maximum velocity called? How many meters did the skydiver fall at maximum velocity before opening their parachute? And then the skydiver's weight was 784 newtons and the gravitational field strength is 9.8 newtons per kilogram. Calculate the mass of the skydiver. So pause the video now, and now unpause the video if you want to go through the answers. Right, so the first one, it's a one marker, so straight away we know it's just a key fact. So what do you call the maximum velocity of a falling object? That's a fact you've just got to learn. It's called the terminal velocity. Now the next one, how many meters did the skydiver fall in maximum velocity before opening up their parachute? So if you notice, what do we know? We know that distance, so speed is equal to distance over time. So therefore distance, my apologies, is equal to speed times by time. So what do we know? We reach a maximum velocity of 50 and we've got 25 seconds. So you do 50 times by 25. So you get your answer out to be 10,000 meters. Now, the next one is we look at the question with a weight here and a gravitational field strength and asked to work out mass. Now this links us into some equations you've got to memorize in GCSE physics. So it's very, very important that you learn your equations. And one of the most famous equations is weight is equal to mass times by gravitational field strength. Now again, if you're doing a higher tier paper for GCSE physics, you need to be able to rearrange this equation. So if weight equals mass times by gravity, mass is then equal to weight over gravity, and therefore you can work it through. Now if you look at how AQA structure their responses, what they like you to do is write out the general equation, weight equals mass times by gravity, then substitute the values in, so weight 784 equals mass times by 9.8, and then do your rearrangement. So you do mass is equal to 784 divided by 9.8 is equal to 80 kilograms. Now again, the last thing you should always do in a physics calculation is check the answer. Does that sound reasonable? For example, if we got an answer for a human of 80,000 kilograms, that's not going to be right. But if it is 80 kilograms, that's about right for an adult man. So therefore, it probably will be right if the answer looks right. So again, 80 kilograms is the correct answer. Right, let's have a look at the following question. Immediately after leaving the aircraft, the skydiver's acceleration was 9.8 meters per second squared. State what happens to the skydiver's acceleration as their velocity increases. Explain your answer in terms of forces. And then what is the acceleration after the skydiver after it's been formed for 25 seconds? State and explain your value of acceleration in terms of forces. So pause the video now and then unpause the video when you want to go through the answers. Right, so the first thing we should know is that when the velocity increases, the acceleration always will decrease. Now why is this? It's the same thing we talked about before with the swimmer, but now it's a different context. It's a skydiver. But remember, liquids and gases are both fluids, so the physics for both of them is exactly the same when you're falling through it. So as your velocity increases, the size of the air resistance or resistive force increases because you're now pushing more air particles out of the way every second as you fall. So therefore the overall resultant force decreases, and the resultant force causes an acceleration. So if the resultant force decreases, the acceleration will decrease. Now what is the acceleration of the skydiver after being fallen for 25 seconds? Well, we saw before in the previous question that it stated that after 25 seconds it had reached its maximum velocity. So if it's at its maximum velocity, it's not going to be accelerating because it is maximum by definition. So the acceleration is 0 meters per second. So the 0 is squared there. Now, what do we know? Why is this the case? Well, a resultant force causes an acceleration. So if you've got no acceleration, you've got no resultant force. So that tells us that the two forces acting on the object, air resistance and weight, are equal to each other, so they both cancel through. Let's have a look at another question. So figure 1 shows a cyclist with a trailer attached to his bike. Describe how Newton's third law applies to the forces between the bike and the trailer. And then a student investigated how the stopping distance of the bike was affected by the mass of the load. The same person rode the same bike throughout the investigation. Give 2 other variables which the students should have controlled. So pause the video now and unpause the video when you want to go through your answers. So it's very important when you look at forces in physics, you memorize Newton's 3 laws. Now, Newton's third law is probably the most famous law out of the 3 of them, and Newton's third law is that when two objects are in a system, they exert equal yet opposite forces of the same size on each other. So there are two objects in this system. There is the bike and there's the trailer. So you would say that the forces of the bike on the trailer and the trailer on the bike are of equal size but are on opposite directions. Remember, it's in Newton's third law, it's the same size and same type of force but opposite directions and opposite objects they act on. Now the next question links into Newton's second law. Now the easiest way to think about it is as follows. We're trying to look at the stopping distance of the bike and how it's affected by the mass of the load. So what have you got to control? Well, think about, when you talk about control variables, anything which would affect the stopping distance which isn't the independent variable, which isn't the mass. So you'd have to use the same trailer each time, have the same weather conditions each time, use the same road surface each time, use the same gradient, have the same speed, or have the same level of alertness. Always think to yourself with a control variable. What needs to be kept the same so it doesn't affect the outcome of the experiment, so nothing affects the outcome except the independent variable. Let's have a look at another question. A student investigated the motion of a glider on an air track. Figure 6 shows the apparatus. The speed of the glider is the same at both ends of the air track. What is the tendency for objects to continue at the same speed in the same direction called? And then the glider has a mass of 0.14 kilograms and a velocity of 17 centimeters per second. Calculate the momentum of the glider. So pause the video now and unpause the video when you want to go through the answers. Right, so it's a fact. You've 1 mark. It's a fact-based question. What's the tendency for objects to continue with the same speed in the same direction called? That is called inertia. So it links into Newton's first law again. We said a resultant force causes acceleration. If there's no resultant force, no acceleration, same speed, so it has inertia. That's just a fact you've got to learn. Now the next one is a couple of things you've got to get you 3 marks. Firstly, you've got to remember that momentum equals mass times by velocity. So you've got to multiply the two values together, but it's worth 3 marks. You should always think to yourself, what's the trick in this question? Where's the third mark coming from? And the third mark is coming from the fact that it's given the velocity in centimeters per second. Because we don't work in centimeters per second in physics, we work in meters per second. So it should be 0.17 meters per second. So momentum is equal to mass times by velocity, so it's 0.14 times by 0.17, so the answer is 0.024 kilograms meters per second. And that looks like a reasonable answer for the momentum of a glider on an air track. So let's have a look at a few questions now on waves. So let's have a look at the following question. One example of a longitudinal wave is either an electromagnetic wave, a radio wave, or a sound wave. And one example of a wave that can be transverse or longitudinal is a light, mechanical, or an ultraviolet wave. And describe the difference between longitudinal and transverse waves. So pause the video now and unpause the video when you want to go through the answers. Right, so you've got to know what waves are longitudinal and what are transverse. Now, the quickest way I can say this is that the only real major wave, which is a longitudinal wave, is a sound wave, which is a fact you've just got to learn. Now, one example of a wave that can be transverse or longitudinal, well, light is an electromagnetic wave, ultraviolet is an electromagnetic wave, and electromagnetic waves are always transverse, so that only leaves us with the option of mechanical waves. Now remember, mechanical waves aren't an example of a wave, they're a category we play waves in. So a mechanical wave is any wave which vibrates particles, like a sound wave is a mechanical wave. So that's always going to be the right answer, because that's a category, not a particular type of wave. Now the last question is a very, very common question on a GCSE physics exam. It asks you to describe the difference between a longitudinal wave and a transverse wave, and you've got to know the difference between the two. So learn them. Now firstly, a wave is a transfer of energy or information from one place in the universe to another, but how they do that is by an oscillation. So a longitudinal wave is when the oscillation of the wave is parallel to the direction of energy transfer, and a transverse wave is where the oscillation of the wave is perpendicular to the transfer of energy. Now another word for direction of transfer of energy is propagation. So you could say a longitudinal wave has oscillations parallel to propagation, and a transverse wave has oscillations perpendicular to propagation. But in your definition, always say what is parallel and what is perpendicular to the direction of energy transfer. It's the oscillation of the wave. Let's have a look at the next question. Describe how radio waves reaching a car aerial produce signals in the electrical circuit of the car radio. Pause the video now and then unpause the video when you want to go through the answer. Right, so you've got to understand how a car aerial works. So a car aerial works as the aerial absorbs radio waves. This causes the electrons in the aerial to vibrate. Now when the electrons in the aerial vibrate, they're moving backwards and forwards, oscillating, which is just an alternating current. So this vibration of electrons is an alternating current, and therefore the signal produced in the car aerial is at the same frequency as the radio wave. You've always got to state that in the aerials, but it does make sense because the thing that's making the electrons vibrate is the radio wave. So the frequency of the vibration is going to be equal to the frequency of the radio wave, which is what the frequency of the AC is. Let's have a look at another question. Light can be reflected and refracted. When light is reflected from a plane mirror, an image is formed. Explain why an image does not form when light is reflected from a wall. And then a wavefront diagram can be used to show the change in wave speed as light enters a glass block. Figure 5 shows a wavefront diagram. Complete the diagram by drawing 2 more wavefronts inside of the glass block. So pause the video now and then unpause the video when you want to go through your answer. Right, so you've got to understand when you get an image from reflection, a very important concept. So specular reflection is when you get an image, diffuse reflection is when you don't get an image. Now what is causing specular and diffuse reflection? Well, it's about the surface. So the wall will have a rough surface, so the light is reflected in all directions, the light is scattered, the reflection is diffuse, so therefore you won't form an image. Now in this next one, we're looking at the wave speed changing. Now if you remember, in refraction it's a very important idea to remember that the speed of the wave changes when you move into a different material. The denser the material, the slower the wave goes, because it's going through a more dense substance, so it's going to take longer time to get through. The other thing you've got to remember with refraction is that it's the wavelength that changes. The frequency of a wave always remains constant. So if we're slowing down, it means that the wavelength must be getting shorter, because speed is equal to frequency times by wavelength. So for the speed to go down, the wavelength must be going down also. Now in this diagram, the wavelength is the distance between the wave fronts. So we should draw in our diagram 2 wavefronts which are still parallel because they hit dead on, so they'll slow down dead on. But now the distance between the 2 wavefronts has got smaller because the wavelength is smaller, because the wave is traveling at a slower speed. Let's have a look at another question. Figure 6 shows a violet light directed at a glass block. So the violet light changes direction in the glass block. Explain why. Draw a line to show the path of violet light as it leaves the glass block. And then the violet light is replaced by red light. Draw a line on the path taken by the red light through the glass block. So pause the video now and unpause the video when you want to go through the answer. Right, so the first one is basically asking you to explain what refraction is. So it's the idea that, like we said before, any wave, in this case violet light, will travel more slowly when it's going through a denser substance, such as a glass block. Now it will then bend towards the normal as it's doing this, because the slower it's going, the straighter the line will get, because the longer time it will be taken to go through, so it'll be bending towards the normal, and that occurs because the glass block is getting denser. So the light travels more slowly, so bends towards the normal because the glass block is denser. Now, what's happening on figure 6? Well, it's the idea that now it's back into air again, so it'll be travelling at its original speed when it entered, before it entered the glass block. So the line should now be at the same angle, it should be parallel to the line that was going into the glass block, because it's now returned to its original speed. So it looks something like this. Now finally, what do you know about red light compared to violet light? Well, red light, you should always remember, has a longer wavelength. The longer the wavelength, the redder the visible light appears. The shorter the wavelength, the bluer or more violet the light appears. So when you got it here, you can see that the red light has the longer wavelength, so as a result refracts less. Now that's an important idea to remember, that the shorter the wavelength, the more the effect of refraction is. That's because there's a greater change in proportion of the wavelength, because you're still changing by a set amount, but now it's a greater proportion of the total value, so it refracts more. So always remember that if it's a longer wavelength, it's a redder light, it will refract less. Let's have a look at the following question. What are the differences between waves A and waves B in terms of frequency, wavelength and amplitude? So pause the video now and then unpause the video when you want to go through the answer. Right, so we need to know what frequency is, what wavelength is and what amplitude is. So let's go with frequency. Frequency is how many waves there are per second. So you can see quite clearly that there are more waves per second in B than in A, because you can measure a wave from peak to peak or from bottom to bottom, or you can go from midpoint to the second midpoint, because it's the equivalent point on the next wave. So you can see in wave B that there's more waves per second, so the frequency is greater. Then the wavelength is the distance from two equivalent points on the adjacent waves, so from one wave to the next wave, so it's easiest to go from peak to peak or crest to crest. So you can see that wavelength B has a much shorter wavelength than wavelength A, because there's a much longer distance between the two peaks for wavelength A compared to wavelength B. And then finally amplitude. Amplitude is the distance from the middle of the wave to the top, or the middle of the wave to the bottom of the wave. So you can see from a bit of measurements very quickly, middle to top for B is a lot bigger than middle to top for A. So B's frequency is higher, B's wavelength is shorter, and B's amplitude is higher. Next one, radio waves are electromagnetic waves. Describe how radio waves are different from sound waves. So pause the video now and unpause the video when you want to go through the answers. Right, so it's worth 4 marks here, so we need to really give 4 different points. Now again, remember when you're giving points, it has to be 4 separate ideas, not just that radio waves are one thing and sound waves are another thing, but it's the same category. So for example, you would say radio waves are faster than sound waves. That is true, but that's only 1 point, not 2, because you're only talking about the speed. So you need to talk about 4 different ideas. So what do you always talk about in terms of waves? You talk about transverse and longitudinal, first thing. So radio waves are electromagnetic. Electromagnetic waves are always transverse, sound waves longitudinal. So there's one difference. Radio waves travel a lot faster than sound waves, because radio waves are electromagnetic waves and all electromagnetic waves travel at the same speed, the speed of light. Next thing is radio waves have a higher frequency than sound waves. That's just a fact you would know. And then finally, you would say radio waves are electromagnetic, so do not need material to travel through. They can go through a vacuum, while sound waves are mechanical waves, so they need particles to travel through. So you can see the link between them there. Now, like I said to you before, it's always important you've got to have 4 different categories or 4 different ideas, as opposed to just comparing and contrasting 2 points. It's got to be 4 separate ones. Let's look at the next question. The motor makes a noise when turned on. Explain the difference in properties between the sound wave produced by the motor and the water waves in the ripple tank. 4 marks. So once again, pause the video and then unpause the video when you want to go through the answer. So you can see again, that's a very, very common question to compare the properties of waves in a GCSE physics examination. So when we look at these ideas, you think to yourself, can we talk about speeds? Well, it's a bit hard to talk about speeds, to be honest, because they can change speeds, water waves. Can we talk about mechanical? No, because they're both mechanical waves and we're looking at differences. So it's probably going to link back to transverse and longitudinal again. And it does. So once again, sound waves are longitudinal. Give the definition of longitudinal. So longitudinal waves are when oscillations or vibrations are parallel to the direction of energy transfer. Again, remember to say what's parallel with what. And then water waves are transverse. In transverse waves, the oscillations are at 90 degrees or at right angles to the direction of energy transfer. Again, always remember sound waves are the only really major longitudinal wave you cover in GCSE. Next question. The period of sound waves is produced by the motor in 8.3 milliseconds. Calculate the frequency of the sound waves. 3 marks. So pause the video now and then unpause the video when you want to go through your answer. Right, so with this one, it has cut off at the bottom there, but you should be using the physics equation sheet. So when you use the physics equation sheet, make sure you write out what the equation is. And the equation is time period is equal to 1 over frequency. Now we then need to rearrange to make frequency the subject, so frequency will therefore be 1 over time period. But again, you think to yourself it's worth 3 marks, so where's the trick? Now the trick is the fact that it's 8.3 milliseconds, so you've got to convert milliseconds into seconds, so you divide by 1,000 because we're going from a smaller unit, millisecond, to a bigger unit, seconds. So you always divide when you go to the bigger unit. So the answer is going to be frequency is equal to 1 over 0.0083, then the frequency is going to be 120 hertz. Again, does that answer look sensible? Yes, it does. So there is your answer. Always think if it's worth 3 or 4 marks, where is the trick in that question? Next question. Explain how a student could make the appropriate measurements and use them to determine the wavelengths of waves in a ripple tank. 6 marks. So pause the video now and unpause the video when you want to go through the answers. So it's worth 6 marks, so once again we need to think about how we're going to structure our response to get the full marks. So the first thing we need to think about is we need to determine the wavelength. Now you should hopefully remember that speed is equal to frequency times by wavelength, so therefore wavelength is going to equal wave speed over frequency. So you need to therefore think about how you determine the speed, how you determine the frequency, and then work out the calculation. So we'll always need a stop clock or stopwatch to measure the time and a meter ruler to measure the distance. So how do you measure the frequency? Well, the frequency is determined by finding the time for several waves to pass through a point. So you find out how many waves pass a point at a fixed time and then work out the time for the average time for one wave to pass through. Remember, it's always better to measure a great number of values and then divide by that value as trying to measure one, as the value would have too much of a high uncertainty or error in there. So you could say I will measure the time for 50 waves to pass through, then divide by 50. You can then determine the speed of the wave by saying speed is distance over time. So you can calculate the distance. You can calculate the distance a water wave will travel, and then time how long it travels that distance, and do speed as distance over time. And then finally, you can do wavelength is equal to the wave speed you calculated over the frequency. Now again, what can you do to increase your accuracy? You can do it over a bigger value, so that will decrease the error. You can use your phone to take measurements, or with like recordings or with photos as well. Always try and indicate all the different things you would do to increase the accuracy. Let's look at the next question. Figure 5 shows a ray of light incident on a semicircular glass block. Complete the ray diagram in figure 5 and draw the ray of light passing through and leaving the glass block and label the angle of refraction. So pause the video now, then unpause the video when you want to go through the answers. Right, so it's important to note that it's going into a glass block. It came from air, so the glass block, is denser than air. So what that tells us is the wave is going to be traveling slower because it's going through a denser medium, and waves take longer to go through denser mediums, especially electromagnetic waves. And so therefore, the light is going to slow down, so it's going to refract and change direction. It's going to go towards the normal, because when light slows down, it goes towards the normal. And then what happens is it's then going to hit the glass block. Now, because the glass block is at an angle itself, it's at a semicircular point, that's actually going to negate any change in direction after that, because it's a curved surface. So what you would see is the following. The ray of light refracts towards the normal when it's into the glass block, but it doesn't refract when it exits the glass block. Now, it's always important to draw in your angle of incidence, your normal, and then your angle of incidence, and then your angle of refraction, because it asks you in the question to label your angle of refraction. Now remember, it's important to note that when we have angles in refraction, it's from the normal, which is an imaginary line which we use as a reference point to measure angles, to the ray. So you can see there where the angle of refraction is. Again, let's have a look at the next question. Explain why the light ray is refracted. 2 marks. So pause the video again and then unpause the video when you want to go through the answer. So it's a very common question in GCSE Physics to explain what refraction is. So refraction occurs when light will travel more slowly in glass than in air, or will travel more quickly if it's going from glass to air, so therefore it will change direction. Refraction is caused by a change in speed, so therefore you observe a change in direction when the actual wave hits the new surface that's going through, or new material is going through, at an angle. Let's have a look at the next question. A student investigated how many different coloured light was refracted by glass. The student aimed to refract rays of different coloured light at a glass block, and she measured the angle of refraction for each colour. Give two variables the students should control, and then the table shows the student's results. Explain why these results could not have been obtained with a normal protractor. So pause the video now, and then unpause the video when you want to go through the answer. So, first thing we've got to think about is, with control variables, what do you have to keep the same so you get some valid results? Now, the colour is the independent variable, is what you're changing, and the dependent variable is what you're measuring, the angle of refraction. So the only thing we want to vary our angle of refraction is the colour. So think to yourself, what else could affect the angle of refraction? And you've got to control them, keep them the same. So the angle of incidence has to be kept the same, because if you change the angle of incidence, it would affect the angle of refraction, and also the type of glass, or the glass block, the material, because the material it's going through would affect how much it refracts as well. So those are the two major answers. Now in this next one, you've got to think to yourself, you look at this here and you think, well, why couldn't a normal protractor do this? Now remember, in a results table you should always give the values to the number of decimal places that the measuring device can record to. So in this particular table it's given the answers to 2 decimal places, and we should know that a protractor does not measure to degrees of to 2 decimal places. So what you call it when you're talking about number of decimal places that a measuring device can measure to, well, that's called a resolution. So we would say that the resolution of a normal protractor is too big, it's too large of a value to get those smaller numbers, because the resolution of a protractor is probably going to be to 1 degree, not to 0.01 degrees, which is 2 decimal places. So therefore you wouldn't be able to measure the difference between the results. So you could not read the angles to 2 decimal places on the results table. Remember, for any results you are given, you should always record it to the same number of decimal places that the measuring device can read to, which is the resolution. So that brings us to the end of this revision session. So if we've been successful and learned in this revision session, we should be able to answer GCSE examination style questions. We should assess our understanding on GCSE physics, and then understand what topics we need to improve upon for GCSE physics. So thank you very much for watching this particular revision session on GCSE Paper 2 for Separate Science Physics. Thank you very much and have a lovely day.